The Pacific Northwest enjoys some of the cleanest water in the country because of its plentiful mountain snowfalls in the winter and above average rainfalls throughout the year, especially during the winter and spring. But that rainfall, which fills up the rivers, can become a hindrance to the clean water. Why? Because when a big storm comes through, the stormwater and sewage are on the same system. As a result, it can overflow and raw sewage dumps directly into the river. Several years ago, the city of Portland set out to protect the river and change the way the stormwater flowed. Their proposal was a grand one. Build 2 giant 5-mile underground pipes, one on the west side and one on the east, carrying water to a large treatment plant on the north side of the city. The west side pipe is complete and the east side is pretty near completion. Don and I decided to check it out.
Andrew, we're going to see the biggest hole in the Pacific Northwest right now today.
That must be a jolly big hole.
It's going to be a big hole.
So why is there a hole? What's it for?
It's about clean water. This is a project that takes the stormwater runoff, the sewage, and keeps it from going into the river. Instead, they're protecting our riverways right here in the city of Portland. We're going to learn about that.
Sounds good. And we're here to meet Paul, right?
Yeah.
Paul? Andrew?
Andrew.
This is Don.
Don. Good to meet you, Paul.
So this is massive. This is not just a little pipe project. It's huge. When did it start?
Well, this construction on this started back in 2006, but we're standing right on top of what we call the upper shaft right now, which is the main mining shaft. 65 feet across, about 120 feet deep, and this is the point where the tunnel boring machine was lowered down and then bored north to Swan Island. We took it out, brought it back, refurbished it here on site. It went back down this shaft and then bored south to southeast 17th and McLaughlin.
So how far is it that direction, south?
It's about 10,000 feet or so, and then about 20,000 feet north. So total of about 5.5 miles.
Great. Is there any chance we can actually get down there to have a look?
I think we could probably get you down there for a few minutes, yeah.
120 feet. It's just as well I don't have a problem with heights. It's a good thing.
Come on, Mike.
Just so you know, this little confined space is designed for 11. There are 1, 2, 3, 4, 5, 6, 7, 8 of us in here. Plenty of room.
With cameras.
With cameras. Can you see? Oh, look out there. Check this out. Check it.
So we're 65 feet across, 120 feet deep, and then the size of these tunnels are what?
These are 22 feet inside diameter. The boring machine itself is a little bigger than 25 feet.
This is an engineering marvel, wouldn't you say? Well, I mean, to be able to drill underneath the river.
The machine that was used was specific to Portland's geology and these particular ground conditions. Right now we're 100 feet under the level of the river right next to us. And this is a type of technology that had been used in Europe for many years, but hadn't been used in the U.S. before we used it on the west side. It worked so well on the west side, we kept the same machine technology on the east side.
So when this is fully operational, how much water can flow through this?
This actually, it's a combination of storage and conveyance. It can store about 80 million gallons. And then the pump station on Swan Island can pump out 220 million gallons a day.
So you can store it and then use it as you need to, or
and then pump it out as the plant can handle it. That's right. So
Okay.
it's designed to be partially full to a normal storm. Large storms, it'll be full.
Holy mackerel.
Look at the size of this thing.
Woo!
22 feet in diameter.
Woo-hoo.
Andrew, the way I understand it, there were 2 boring machines named Lewis and Clark, and they travel at 1.5 feet an hour. Drilling, cutting into
slow.
Yeah.
Let's go through granite. And if you have a look at the sections, right? Each one of these is laid down separately, individually. Then once they're complete, they're so well engineered that when the backfill comes in around them, it pretty much completely seals the tunnel. And I'm told that this is an exceptionally dry tunnel, especially after it's going underneath a river. I mean, this is pretty impressive stuff.
Yeah, we're 100 feet below the Willamette River right here. Eventually, I understand, they'll fill this hole in, Andrew.
It's going to be sealed out. I mean, you really don't want a hole this big in the middle of your downtown area.
So they got quite a few of these around, though.
There's holes all over the place.
That's right.
But this is the biggest one of the lot.
Yeah.